All right, so we can create new functions from other functions, right? And one way that we can do that is to multiply two functions together and we get a new function. Or we could take two functions and divide them, right? And then we get a new function. So in this section, we're going to learn the product and quotient rules. So we're going to learn the rules for taking the derivative of the product of two functions or the quotient of two functions. All right, so let's start with the product rule. Now, I like this area model representation here. Let me scroll down a little so you can see the whole thing. We can represent the product of two functions with area, right? We have length times width as area. And so we can represent this g of x times f of x or f of x times g of x as the area here, okay, where v is g of x and u is f of x, okay? And then f of x times g of x is u times v, and we get the area of a rectangle. Now, when we're taking the derivative, we're looking at the average rate of change of the function. So if we change x by a little bit, what we'd like to know is how much does the function change, okay? So we change x by a little bit, which changes u by a little bit. That's the delta u. And it changes v by a little bit, and that's the delta v. And you can see the change in the area. This is the shaded region there. And the area of that change, right? That's the change in the function, this new function f of x times g of x. And so you can see there's three components to it, right? There's the length u times the little delta v, and there's the length v times the little delta u. And then we have that little corner up there, delta v times delta u. All right. Now, average rate of change is the change in this function, which is a product. It's the change in the product f of x times g of x over the change in x, right? And so we can represent the change in the product as delta u times v plus u times delta v, and then plus that little corner, delta v times delta u. Now we want to let the change in x go to 0, right? So the rate of change is the change in the product over the change in x, right? And then so we just divide everything by delta x, and here's what we end up with. Now, as you let the delta x go to 0, you can see that delta u over delta x becomes du dx, which is the derivative of u, right? The delta v over delta x as x goes to 0 becomes dv dx. That's a comma, by the way. That's not a prime symbol or anything. That becomes dv dx, which is the derivative of v with respect to x. And then the delta u goes to 0. So this last term, which is delta u times basically dv dx, goes to 0. Okay? So the product rule, here it is. Here it is. The derivative of a product, right? If we have the functions u and v, the derivative of the product is du dx times v, all right? So it's the derivative of the first function in the product times the second function in the product plus u times dv dx. Okay, so that's the first times the derivative of the second function. All right, so so you can write it this way using Leibniz notation, or you can see down here we've written it in function notation. So so the way I remember it is I just remember when I take the derivative of a product, I take the derivative of the first times the second plus the first times the derivative of the second. That's sort of the way I think about it, where the first is the first function, right? In this case, f of x, and the second is g of x. All right. So, okay, this takes some practice. So let's do some practice. Let's take a look at this first example now. So in the first one, we have the product of 3x to the fourth times e to the x. So now we actually have 3 times x to the fourth times e to the x. But we know that we can take the derivative of a constant multiple of a function pretty easily. So I would probably put these two together into one function, and then this will be my other function. Okay, will just be the e to the x. Now I'm going to show you a method that I learned from another professor, Dr. Martelli. And she showed me this, and I was like, did you come up with, or I was like, where does this come from? Does it have a name? And she said, no, this is just the way I've always done it, the way she organizes her work. And I was like, oh, okay. And it seems to help a lot of students, especially when they're first learning it. Okay, so I will show you the method. We'll call it the Martelli method. Okay, so so what she does is you could draw a box, or I'm just drawing kind of a crosshairs here. And up here I'm going to put the first function, right? 3x to the fourth. Okay, and then below it I'm going to put the e to the x. So these are the original. So I'm going to I'll write original up here. Original functions, right, that we have in this product. And then we're going to take the derivative of each of those. So I write derivative over here. We take the derivative of each one of these, and that's easy enough. Derivative of 3x to the fourth is 12x cubed, and the derivative of e to the x is e to the x. Boom. All right. Now, we're going to put some arrows here. All right, and then I'm going to write, now it says y, so I'm just going to write the derivative as dy dx. So I'm labeling my derivative because it's a new function now. And all I need to do is follow the arrows, right? I'm going to take the first, you see this first arrow here, right here. I'm going to multiply these functions together. I'm going to get 12x cubed times e to the x. All right, and then I'm going to multiply the functions along the other arrow. I'm going to put a plus in the middle because the product rule has a plus in the middle. And so I get 3x to the fourth e to the x. Okay. So that might be a good way for you to organize your work when you're first learning this. All right. But to be honest, in the long run, it's good to like just be able to write it directly. And the way that I think about it, I take the derivative of the first, right, which is the 3x to the fourth. So I'm going to take the derivative of 3x to the fourth, write that down, times the second as it is, plus the first, right, as it is, times the derivative of the second. Okay, so there you go. Okay, so we did the first one. Now, I think I'll use the box method, the Martelli method on this one as well. So I'll draw my little, I sometimes call it the box method, but now I'm calling it the Martelli method because I give her credit for this method. All right, so I have two functions multiplied together. It looks like the first one is the square root of t. So I'm going to write it as t to the 1/2 because I want to use the power rule on it. And then the second function is 2e to the t minus t. All right, those are the two original functions that that are multiplied together. All right, so and then on the right hand side here, I'm going to take the derivative of each one of these. All right, so I've got 1/2 t to the minus 1/2. Okay, or if you've memorized the derivative of the square root is 1/2 square root of t, that's fine too. You could write that. And it looks like, oops, I just realized I put an x here and I meant t. So and then we take the derivative of the second function, and we're going to get 2e to the t minus 1. All right, we can then draw the arrows, and then we're going to multiply these together. So I'm going to label it h prime of t because it's a new function. And then I'm going to multiply the first diagonal. So I'm going to take, now you could write it either way, 1/2 t to the minus 1/2, or 1/2 square root of x, either way. or square root of t. And then I have to put this in parentheses, 2e to the t minus t. Okay, and then we're going to add the product of the other diagonals. So t to the 1/2, and then again in parentheses, 2e to the t minus 1. All right, there we go. So let's keep going here. Let's see this next one. Now I can use the box method again on this. So let's just go ahead and do that. So the first function I'm going to call 5e to the x. All right. Now, the next one is a cube root squared, right? And let me make that a little straighter. Okay. It's a cube root squared. All right. So I need to simplify that because I don't, I need to have it it's got to be a power function, right? So the cube root is 1/3 power, and then when you take a power to a power, you multiply the powers. So this is the same thing as x to the 2/3. I'm just going to write x to the 2/3, and then I'm going to take the derivative of each one of these, 2/3 x, and I subtract 1, I get a negative 1/3. And then I can draw my arrows. And then I'm going to multiply the first diagonal. Now I'm going to label it first f prime of x. All right, this is a new function. We'll label it and then multiply the first diagonal. We're going to get 5e to the x times x to the 2/3. And then plus 5e to the x times 2/3 x to the minus 1/3. Boom. Done. All right. Now you might be able to simplify that, but it's fine. Just leave it that way for now. We're just, I just want to make sure you know the product rule. And so, all right. Now let's look at this next one. So this one, I don't like that 2 in the denominator. I kind of want to just make it a product. So I'm probably going to start by rewriting this as 1/2, right? Dividing by 2 is the same as multiplying by 1/2. X times e to the x plus 1. Okay. Now you could distribute, but you'd still need to use the product rule in the first term, because if you distributed, you get 1/2 x e to the x. And then plus 1/2 x. But so you might as well just leave it this way. You have to use the product rule either way. So again, I'll use the box method. If once you get the hang of it, you may not need the box, but it's helpful at first. Okay. So my two functions are 1/2 x, and the other function is e to the x plus 1. All right. Take the derivative of each one of these functions, and I get 1/2, and then e to the x, right? Just e to the x, because the derivative of the constant is 0. And now I can draw my arrows, and then I'm going to write g prime of x equals, all right? We're going to label it. It's a new function. It's the derivative now. So I just need to multiply the two diagonals. So I have 1/2 times e to the x plus 1, right? You have to have the parentheses around that because we're multiplying 1/2 times the whole function, not just part of it. And it's the product rule, so we have a plus in the middle, and then we're going to have 1/2 x e to the x. And we're done. All right. So you just need to practice that. And the next thing we're going to talk about is the quotient rule, which is what you need to use when you have the quotient of two functions, when you're trying to find the derivative of a quotient of two functions. All right, so I'll see you in the next video.